CPM Math 3, Problem 3-61. We're being asked to solve algebraically some pretty crazy looking equations here, and we're going to go through each one of them, so this is going to be a little bit longer of a video than what I normally do, but I do want to kind of talk about the strategies for each one. So let's start with problem A. So problem A has kind of a not so fun fraction right here that we kind of are tempted. One of our instincts right now, I think that we've been taught, is to take this -3 and distribute it into the parentheses. And if you do that, you're going to end up with -3/2 x, which is, very doable. We could probably do that. But I just want you to think about other alternatives. And so we're going to approach this problem a little bit different so that you know what math that we can actually use along the way that's legal. So because this 5 is kind of far away from the variable, it's not impacted in any multiplication, I'm actually going to subtract 5 from both sides just to see what happens. And honestly, I don't know if this is going to work or not. Maybe we need to not tackle it this way, but that cancels, and I'm left with -3 times 1/2 x plus 2 equals -7 minus 5 is -12. All right, so at this point, I have some number here, -3, times some number here, this 1/2 x plus 2. So because -3 is being multiplied by a quantity, it's just a factor. So I can actually divide by -3 on both sides. And you have to be careful when you use that approach because it has to be some number times the whole other number. So by doing that, we get rid of the -3 over here, and I'm left with 1/2 x plus 2 equals -12 divided by -3 is +4. Woo, we got rid of the negative. So at this point, this is like one of your problems you would have seen in maybe 7th or 8th grade, solving a two-step equation. So let's subtract 2 from both sides, and we get 1/2 x equals 4 minus 2 is 2. And I'm going to use the multiplicative inverse, which says if I multiply both sides by the reciprocal, and I will get rid of that fraction. It's a very common technique that is used that is actually very helpful. So we end up with x equals 2 times 2 over 1, x equals 4. And that was not too complicated. I'm really glad it worked out. Although if you did choose to distribute that -3, you would get the same answer, but you'd have to deal with some uncomfortable fractions along the way. All right, let's move on to number B. And oh heavens, this little guy does look a little complicated, but we're just going to use that whole undoing process and, what we can do algebraically. So this is saying 5 times this quantity here, as weird as that is. And all we really need to do, I think, is divide by 5, and we can move that 5 over to the other side. And then we're simply left, the 5's cancel, we're left with the square root of x minus 2 plus 1 outside equals 15 divided by 5 is 3. At this point, oh, that doesn't look so bad. So now I can subtract 1 here. That would be totally legal to do. And I'm left with the square root of x minus 2. Those guys cancel, equals 3 minus 1 is 2. I think I've done everything correct. And then if I square both sides, look at how easy this is getting. If I square both sides, the square and the square root cancels. I'm left with x minus 2 equals 2 squared is 4. And now I can add 2 to both sides, and I end up with x equals 6. Is it really that easy? Let's check our answer just to be sure. So we're going to take 5 times the square root of 6 is now x minus 2. Whoops, I'm going to erase that little edge so it doesn't confuse us. Plus 1 equals 15. Okay, so wait, where's my parenthesis? There it goes. All right, so 5 times the square root of 4 plus 1 equals 15. Let's see, 5 times square root of 4 is 2. Plus 1 equals, oh, look at that. 5 times 3 does indeed equal 15. So that checks. We did it right. Cool. Yay. All right, let's move on to problems. All right, and for this guy, I do notice that I'm subtracting this quantity here. The 12 is positive, and he's attached through addition or subtraction. So I'm going to get rid of this 12 and move him over so that my parenthesis is kind of left alone. It's kind of like peeling an onion, I guess. So I am going to subtract 12 from both sides. And let's simplify that. And one of the things this is now, this negative is attached to this guy. It's not attached to the 12. So we end up with negative 2x over 3 plus x equals 2 minus 12 is negative 10. Okay, so this is essentially a negative 1 right here times the quantity here. So I'm actually going to divide by negative 1. I'm totally allowed to do that. I'm not breaking any math rules. And then I end up with 2x over 3 plus x. The parentheses now are gone because I've gotten rid of that negative. Equals negative 10 divided by negative 1. Oh, how convenient. Now it's positive. So now we can actually use our fraction buster strategy. I think I'm going to multiply everything, every term, by my least common multiple. And in this case, my least common multiple is 3. And so I'm going to rewrite it as 3 over 3 times 2x. And this is a 1, so I'm going to write it as 3 over 1 times x equals 3. There's technically a 1, 3 times 10. Okay, so this is, we did do this in class, so 3 over 3 cancels, and I'm just left with 2x here. 3 times x is plus 3x here, equals 3 times 10 is 30. Now I end up simply with 5x equals 30. I can divide both sides by 5, and x equals 6. Let's check that. All right, so I took a moment to substitute, and I'm going to end up with 12 minus 12 over 3 plus 6 equals 2. Let's see if that works. 12 minus 4 plus 6 equals 2. 12 minus 4 plus 6 is 10 equals 2. 12 minus 10 is 2 equals 2. It checks. Good enough. All right, on to part D. Oh my gosh, this is cool. Okay, so we have negative 3 times this quantity cubed. Oh, wow. All right, let's first, so it's basically negative 3 times 2x plus 1 times 2x plus 1 times 2x plus 1. So because that's technically all multiplication of factors, because this little parenthesis holds it together as a factor, I'm actually allowed to divide by negative 3 on both sides. And when I do that, the negative 3's cancel, and I'm left with 2x plus 1 cubed equals negative 192 divided by negative 3. Use my trusty calculator, and I get positive 64. Okay. Ooh, okay, so now that's kind of weird. How do you undo cubed? Well, I'm just going to take the cube root of that little guy, but what I do to one side, I have to do to the other. So I have to take the cube root of 64 as well. So the cube here and my cube root cancel. Oh, how convenient. 2x plus 1 is all that's left. And so some number times itself 3 times equals 64. 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. So the cube root of 64 is 4. Ah, look at that. So minus 4 from both, or minus 1, excuse me, from both sides. And I get 2x equals 3 and divide by 2. And I get x equals 3 halves. And I do think, as inconvenient as it's going to be, we're going to go ahead and take a moment to check that. All right, so I just substituted my 3 halves answer here in for x, and let's see what happens. All right, so negative 3 times 2 times 3 is 6, divided by 2 is 3, plus 1 cubed equals negative 192, and negative 3, we have to do the inside the parentheses first, so 3 times 1 is 4 cubed equals negative 192, and then we get negative 3 times 4 times 4 times 4 is 64 equals negative 192, and negative 3 times 64 is negative 192. Holy cow, it checks. Negative 192, check, we are golden. All right, I know this was a little bit of a longer video, but it's totally helpful for our algebra skills.